When astronomers discuss the cosmos's large-scale structure, they often describe space as curved or the universe as finite but unbounded, a massive, unintuitive concept. To understand what they mean, we first have to recognize our biological limitations. We navigate reality using exactly 3 directions. We know left and right, we know forward and back, and we know up and down. Yet the math describing our universe strongly suggests that a 4th physical dimension exists, positioned simultaneously at right angles to those familiar 3. The problem is, your brain is completely incapable of picturing this. If someone asks you to point left or point up, you do it instantly. But if asked to point to that 4th direction, you can't. Because we can't physically see this higher dimension, we have to bypass our spatial intuition. And the best way to do that is to restrict our perspective even further, shrinking our reality down to a completely flat, 2-dimensional world. Imagine a universe designed by the Victorian scholar Edwin Abbott, aptly named Flatland. It is a strictly 2-dimensional plane. The inhabitants here are exceptionally flat squares, circles, and triangles. They have length and width, but absolutely no concept of height. Now, suppose a 3-dimensional creature, say something shaped like an apple, hovers just above Flatland. Looking down, it spots a congenial square and decides to say hello. To the square, who cannot perceive above, the greeting seems to be echoing from directly inside his own closed 2-dimensional body. Unsettled by the voice, the apple decides to physically enter Flatland to prove its existence. But a 3-dimensional object can only partially exist in a 2-dimensional world. When the bottom of the apple touches the plane, the square sees a single mysterious point appear out of thin air, right inside his closed room. As the apple slithers downward through the plane, the square watches this point rapidly expand into a widening circle, and then shift its shape organically. The laws of physics are breaking right in front of him, simply because a higher dimensional object is passing entirely through his flat reality. Annoyed that the square assumes he's just losing his mind, the apple makes contact from underneath and bumps the flat creature up, fluttering and spinning into the 3rd dimension. For a moment, the square is utterly disoriented, but soon he realizes the advantage of his new vantage point. By looking down onto his flat world, he can suddenly see inside closed rooms. He can see the internal structures of his fellow Flatlanders. He has acquired X-ray vision, merely by existing 1 dimension higher. Eventually, the square descends back to his home plane. His friends rush over, demanding to know where he vanished to. He tries to explain this strange, mystic dimension called up, but when they ask him to point to it, he completely fails. He is physically trapped back in 2 dimensions. This tells us something crucial about interacting with higher planes. When a higher dimensional object intersects with a lower dimensional world, the inhabitants don't see its true form. They only experience disjointed cross-sections and seemingly impossible physical anomalies. We can apply the exact logic of Flatland to pure geometry. Let's look at how dimensions scale. Start by taking a 1-dimensional line segment and moving it parallel to itself at a perfect right angle. That traces out a flat 2-dimensional square. If we take that 2-dimensional square and move it at a right angle to itself along a 3rd axis, we generate a 3-dimensional cube. Now follow that exact same mathematical rule 1 step further. Take that 3D cube and carry it at a right angle into an unseeable 4th physical direction. The resulting shape is a 4-dimensional hypercube, known as a tesseract. We can't show you a true tesseract because, like the Flatlanders, we are locked in our specific dimensionality. However, higher dimensional objects cast shadows down into lower dimensions, just as a 3D cube casts a flat 2D shadow onto a piece of paper. What you are looking at here is a tesseract's shadow cast down into 3-dimensional space. It appears as 2 nested cubes with all their corresponding vertices connected. Notice how the lines don't all look equal, and the corners aren't 90 degrees. This is the penalty of projection. In the actual 4th dimension, every single line of this hypercube is the exact same length, and every angle is a perfect right angle. The distorted angles only exist because the shadow is squished into our lower reality. Even though we are trapped in 3 spatial dimensions, our math isn't. We can calculate, define, and perfectly understand the shape of a higher dimensional object using only the imperfect shadow it casts into our world. Let's apply that logic to Flatland with a geographic twist. Imagine their 2-dimensional universe is, unbeknownst to them, curved into an enormous sphere. Locally, it looks perfectly flat. A Flatlander sets out to explore, walking forward along what he perceives as a straight line. He never alters his course, he never turns around, he never hits an edge. Yet, after a very long journey, he finds himself standing exactly back at his starting point. The Flatlander couldn't possibly picture the 3D globe he just circumnavigated, but by arriving back where he began, he can definitively deduce that his apparently flat universe is actually curved. Now, increase all the dimensions in that story by 1. Our space contains immense gravitational mass that warps reality. Many cosmologists suggest this mass bends our enormous, seemingly flat 3-dimensional universe back on itself into a 4-dimensional sphere. Like the Flatlander, we are 3D creatures trapped in a 3D perspective. We can calculate and talk about a 4th physical dimension, but no human eye can ever look up and point to it. But we don't need physical sight to prove that higher dimensions exist. Through mathematics and careful deduction, we can examine the shadows cast onto the walls of our universe and comprehend the invisible geometry beyond our reach.